So at this point in the Math 142, if you've watched all the previous videos that I've posted in Canvas, you have been practicing finding your way around the unit circle. So you should be able to, if I say something like 5 pi over 4, you should be able to tell me exactly where you're at in the unit circle. 5 pi over 4 would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So it'd be right here. That would be 5 pi over 4. So anyway, hopefully you've been practicing that. If you don't know what I'm talking about, you need to go back and watch video on Canvas. It's in the trig functions module, and it's under the very first thing in that module is the teaching videos for concepts assessed in homework 1. And it is the, well, it's the first video and the third video. They both help you. Okay, so what we're going to do in this video is introduce a new idea called the wrapping function. And the idea is that you wrap around a circle and it produced certain things. So the wrapping function is w of x, or of theta, actually. And you plug in an angle measure. Oops. An angle measure. And you can measure that in radians or degrees. Both work. And then that's the input. The output is the coordinates of the point where the terminal side of the angle intercepts the unit circle. Again, by unit circle, we mean a circle of radius 1. So, for example, if I said the wrapping function of 45 degrees, that means I would go right to here, and I'd be looking for the coordinates of that point. Okay, so how do we do that? You should be able to do this off the top of your head. And this is not something to memorize. This is a method to learn and understand, and if you understand it, it should be with you for the rest of your life, actually. I was just going over this in my Calc 3 class, and I think there's 6 people in there that I asked them to find, I think it was sine of 2 pi over 3, and they immediately began, I could see them kind of drawing circles in the air with their fingers, and they were able to come up with the value. And this is, Calc 3 is usually, that's 2 or 3 semesters or quarters after this class. So it's something that should stick with you. And the method that I'm about to teach you should help that stick with you. So the idea here is we're only looking at a certain number of angles. We're looking at the 45 degree multiples and the 30 degree multiples. And if you've watched the video on getting to know radian measure better, I basically introduced 2 different circles. The reason these are both unit circles, they're the same thing. It's just that it's helpful to draw lines. So when you're looking for multiples of 45, you look in this circle. And when you're looking for multiples of 30, you look in this circle. So one of the fundamental ideas is that 45 degrees is the same thing as pi over 4 radians. And here, 30 degrees is the same thing as pi over 6 radians. And then the next thing that's really important is we notice that there are some triangles in here. If I drop a line, a vertical line from the intersection of the terminal side of the angle to the x-axis, we form a bunch of right triangles. So here's a right triangle. And we know that this angle right here is 45 degrees. Which makes this one up here also 45 degrees because they have to add up to 180. So 45 plus 45 plus 90 equals 180. And notice all these triangles are all 45 degree angles. I'm sorry, all these triangles are the same triangle. They're what we call a 45, 90 right triangle. Or 90 and right mean the same thing. And notice over here, if we drop those same lines, we have a couple different triangles formed, although they're really the same, just in different orientations. So since this is 30 degrees, that would make this 60 degrees. Likewise, if this is 60 degrees, that would make this 30 degrees. So this is what is called a 30, 60, 90 triangle. And these are, if you had geometry, some of you probably had geometry a long time ago, but or maybe even Algebra 2, they have a little trig section. They introduced the right triangle trigonometry. And one of the first things you learn is there's two special triangles, the 45, 45, 90 and the 30, 60, 90. And in the 45, 45, 90, like all right triangles, there's a certain ratio to the sides. And in this case, since we're dealing with a unit circle, both these circles have a radius of 1. We know that the hypotenuse is 1. Oops, sorry. And because of the special relationship, the relationship between the hypotenuse and the legs is a multiple or a factor of square root of 2. So to go to here, we'd have to divide by square root of 2. If we're going from the legs to the hypotenuse, we'd multiply by the square root of 2. So this length is going to be 1 over square root of 2, and this is going to be 1 over square root of 2. Likewise, on the 30, 60, 90, the hypotenuse is 1, and the short side of a 30, 60, 90 triangle is always half the hypotenuse, so I'd make this 1/2. And the long leg, or the longer leg of the 30, 60, 90 is always square root of 3 times the short leg, so this would be square root of 3 over 2. So these triangles right here, if you don't have them already, you need to memorize them. Because, as I said, when you come back up to these circles, these 45, 45, 90 triangles are in this one, and this one's populated by 30, 60, 90 triangles. And why do we care about that? Because remember, the wrapping function wants to know what this coordinate is. And this coordinate happens to be, the x-coordinate happens to be the length of that triangle, and the y-coordinate happens to be the length of that side of the triangle. So the coordinate at this point would be 1 over rad 2, comma 1 over rad 2. Likewise over here, 30 degrees. So what's the coordinate at this point right here? Well, that distance right there is the long side of the 30, 60, 90, so that'd be square root of 3 over 2. And that distance right there is the short side of the 30, 60, 90, so that'd be 1/2. So that's the system. So you have to memorize these triangles. So then when I say, what's the wrapping function for, say, 150 degrees? Well, then I try to draw one of those triangles. This is a multiple of 30. So I think about this one. 1, 2, 3, 4, 5. That would be 150 degrees because it's 30, 60, 90, 120, 150. So this is the triangle I'm talking about. Forget about this other things. That's the triangle I'm talking about. Notice it's a 30, 60, 90 triangle. The short side is over here, and the long side is over here. So that means the x-coordinate would be rad 3 over 2, and the y-coordinate would be 1/2. But then I remember that this is a xy plane, right? So since I'm going to the left for my x-coordinate, that would actually be negative. So I put a little negative there. And I'm going up for my y-coordinate, so that would be positive. Again, we're just using what we know about the coordinate system, that you know that if you go to the left, that's a negative x value, and if you go up, that's a positive y value. If I would have went to the left and down, that would have been a negative x value and a negative y value. Okay, so let's try another one with that same. What if we did wrapping function of, say, 7 pi over 6? Well, that would be, this is 5 pi over 6 right here, because you got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Or you could think of this as 6 pi over 6. So that means 7 pi over 6 would just be 1 more pi over 6 past it. So it'd be right there. And again, that's a 30, 60, 90 triangle with a 30 angle down there. So this is the short side, because that's 30 degrees. This is the short side, so that would be 1/2, which happens to be the y-coordinate. And that's the long side, so that would be rad 3 over 2. And since they're going to the left, that would be negative. And since you're going down, that would be negative. Okay, I'll give you a couple more examples. The wrapping function for 5 pi over 4. Again, you know how to find your way around the unit circle, right? So 5 pi over 4, let's see, that's 1 pi over 4 right there. 2, 3, 4, 5 pi over 4 is right there. Could have got there quicker by saying, oh, this is 4 pi over 4, I know, so 5 pi over 4 would be one more. But however, you get there, and you notice that this is a 45, 45, 90 in the third quadrant. So they're both negative, and they're both the same, because it's 45, 45, 90. So this would be negative 1 over rad 2, and negative 1 over rad 2. Let's see, one more. How about 90 degrees? We haven't talked about that. So 90 degrees we know is right here. And there is no triangle. But that's okay, because if we're looking for the coordinates, we can still find this coordinate without a triangle. Because the coordinates at this point we know, since the radius is 1, that right there would be 1. So that means I've gone to the right or left 0, and I've gone up 1. So the coordinates of this would be 0, 1. What about the wrapping function of 3, let's say 2 pi? Yeah. Where's 2 pi? That's one trip completely around the circle, so that is sitting right there. Don't need much thought to figure out that that's going to be to the right 1 and up or down 0. So that would be the point 1, 0. Okay, folks, that's the wrapping function. Again, you got to memorize those two triangles, and you've got to get better and better at finding your way around the unit circle. I think thinking of it as in two different forms, I think is helpful. But you do whatever makes it efficient for you. Okay, again, the goal here is to be able to do this without using a pre-drawn unit circle. You got to be able to generate these numbers off the top of your head with maybe a quick little sketch. Okay?